In the last lesson, we looked at the extraction of iron in the blast furnace, and in this video, we're going to look at another phenomenon that's related to iron, which is rusting. Now, rusting is essentially the reaction of iron with oxygen and water. And when iron reacts with oxygen and water, it forms a product called hydrated iron 3 oxide. So the reddish brown solid that we see as rust is actually hydrated iron 3 oxide or iron 3 oxide with water of crystallization. Now from the equation shown, I hope you can see that there are two things that are necessary for rusting to occur, or there are two ingredients for rusting to occur. The first of which is the presence of oxygen, and secondly is the presence of water. Okay, another important thing to take note is that rusting is actually faster when you have a salt solution, or rusting occurs faster in salt solutions or in acidic solutions. Okay, reason being the ions in these solutions, they actually speed up the reaction. Now let us take a look at this question where we need to analyze the conditions in each of the test tube to see whether the nail will rust. Now in this seemingly very innocent question, there are actually many new ideas to be learned. Okay, so let's look at test tube A. Test tube A, the paper clip is immersed in water. However, the water is boiled. Okay, so what is the purpose of boiling? What's the difference between water that has been boiled versus water that hasn't been boiled? Is this: that boiling actually removes the dissolved gases. Alright, so meaning boiled water would have O2 removed from it. Okay, so there's no oxygen present. And what's the purpose of having a layer of oil above the water? Is this: that there's still air in the test tube, so it prevents oxygen from redissolving into your boiled water. Alright, so essentially, if we look at the conditions needed for rusting, in A, we have water, but we have no oxygen, so rusting will not occur. Okay, let's look at B. Now in B, we have air. Okay, so in air we have oxygen. Do we have water? We have no water present. Okay, actually it's not very clear. It's not mentioned whether the air is completely dry, but in this case, what makes me even more sure that rusting will not occur is that you have greased paper clip. Alright, so what happens is that there's a layer of oil on your paper clip, and this oil will prevent any moisture or water from coming in contact with the iron. In test tube C, we have tap water. Notice that the tap water is not boiled, so meaning there is oxygen in there. Alright, and there is water in there. Okay, so the two conditions for rusting are met, and that tells us that the paper clip in test tube C will actually rust. Let's look at test tube D. Test tube D has a drying agent in there. Alright, the drying agent it can be, or usually it is your anhydrous calcium chloride. So what a drying agent does is that it absorbs all the water, so that there is no water around. The cotton wool serves a similar purpose. It's acting as a barrier to slow down oxygen and moisture from reaching the paper clip. So in this case, even though there is oxygen, there is no water due to the drying agent, so the paper clip in test tube D will also not rust. In the next part of the video, we're going to look at the methods that we can use to prevent rusting. Okay, and there are three main methods. To remember the three main methods, this is the analogy that I usually use. Now imagine if you are extremely rich, you are filthy rich. So when you go out in the streets, how do you prevent yourself from getting robbed? Okay, I repeat again, you are filthy rich. When you go outside, how do you prevent yourself from getting robbed? Okay, so some ideas that you may be able to think of. Number one is to hire a bodyguard, correct? Now, how does a bodyguard help you? So in the time where a robber turns up, your bodyguard is actually going to stand between you and the robber. So your bodyguard will serve as a protective barrier that protects you from the robber. Okay, so one way is to hire a bodyguard. Next way is very interesting. When you go out with friends who are richer than you. Okay, how would that help you from getting robbed? Because if you encounter a robber, the robber will rob your richer friends instead. Okay, so this method later we'll see is that you get your richer friends to sacrifice for you. Okay, the third method, if you are very rich but you are very stingy, you don't want to hire any bodyguards, then you go out with friends who have bodyguards. Alright, so when the bodyguards are guarding your friends, they will guard you as well. Okay, this method is known as formation of alloys. So as mentioned, there are three main methods for preventing rusting. The first method is to use a protective layer. So imagine I have a strip of iron over here, so I can coat it with a protective layer. Now this protective layer can be anything from oil to plastic to even another metal. Alright, so what this protective layer does is that it prevents oxygen and water from coming into contact with iron. So if oxygen and water cannot come into contact with iron, rusting cannot occur. Now the method of coating iron with another metal, it has a special name. It's called electroplating. Reason being, it involves electrolysis, which is what we will see in a later chapter. The second method that we can use is called sacrificial protection. So what we do is that we attach a more reactive metal to iron, for example magnesium. Okay, the principle of sacrificial protection is that you don't have to cover the entire metal with the more reactive metal. We just need to attach the more reactive metal to iron. Okay, so what happens is that in the presence of water and oxygen, magnesium will sacrifice itself. It will react with oxygen and water in place of iron. Okay, so as mentioned, you don't need to cover the entire metal. So sacrificial protection is usually used for very huge structures or in ships, where we only need to attach a piece of a sacrificial metal to protect iron from rusting. Okay, and the thing about the sacrificial metal is that it will be gone in no time, so we need to replace it regularly in order to protect the iron. The third method is alloying, meaning to combine iron with something else, another metal or another element. So for example, stainless steel is a combination. Steel is a mixture of iron plus carbon, and in stainless steel we add chromium as well. Now, so how does adding chromium into steel protects it from rusting? Is that chromium has its own protective oxide layer. Alright, it has a protective oxide layer. So when you add chromium into stainless steel, the oxide layer protection is given to the entire steel as well. So it prevents your steel from rusting easily. Now in the last part of the chapter, we're going to look at the recycling of metals, or why do we need to recycle metals. And the most important reason is that metals are finite resources, meaning they are limited. Once we have finished mining all the ores, there will not be any metals left for us to extract. Okay, so we need to conserve them to make them last a longer period of time. Next is that from the extraction of iron in the blast furnace, we can see that extraction of irons can actually produce a lot of harmful gases like carbon dioxide, nitrogen dioxide, nitrogen monoxide. Alright, so all this, the extraction of metals would bring about air pollution, which is what we don't want, which is what we can reduce if we recycle metals. The other thing is that if we don't recycle metals, we will have to discard them in landfills, and that will cause land pollution as well. Okay, now in some places you may see this cost. So a benefit of recycling is to save cost. Now that is debatable. Alright, so as much as possible, please do not write saving of cost or saving of money as a benefit of recycling, because sometimes recycling can cost more money than extraction of metals.